Welcome to Proving the Concept, the podcast where we delve into the weird, wonderful, and sometimes bizarre world of science and technology. I'm your host, Sarah Goffin, and today we're diving into a topic that's as colourful as it is enlightening: spectacular spectroscopy. The scientific techniques that let us peel back the layers of the universe and see what's really going on at an atomic and molecular level. From how we analyse distant stars to understanding the inner workings of the human body, spectroscopy has shaped our understanding of the world in incredible ways. So grab your lab goggles and get ready for a spectacular journey through the history, techniques, and quirks of spectroscopy. And as always, we'll shine a spotlight on an extraordinary scientist who helped shape this fascinating field. Spectroscopy has a surprisingly long history that stretches back to the 17th century. It all started with a curious scientist you might have heard of, Isaac Newton. In 1666, Newton passed sunlight through a prism and discovered that white light could be split into a rainbow of colours, or a spectrum. This simple yet profound experiment was the foundation of what we now call spectroscopy. Fast forward to the 19th century, and the field started to heat up. Literally. Scientists like Joseph von Fraunhofer observed dark lines in the spectrum of sunlight, which we now know are absorption lines caused by elements in the sun's atmosphere. These discoveries laid the groundwork for what would become the science of understanding matter through its interaction with light. But spectroscopy didn't stop at visible light. With the advent of quantum mechanics in the 20th century, scientists began exploring other parts of the electromagnetic spectrum: infrared, ultraviolet, and even radio waves. This expansion unlocked a treasure trove of information about the universe and its building blocks. Now let's talk about some of the coolest spectroscopic techniques out there. First up, we have nuclear magnetic resonance spectroscopy, or NMR. NMR is the reason we can perform MRIs in medicine and map the structure of complex molecules. It works by exploiting the magnetic properties of atomic nuclei. Imagine spinning tops in a magnetic field. NMR helps us to tune into the resonance frequencies of these nuclei to determine their environment. Then there's mass spectroscopy, or MS. If NMR is the detective in the lab, MS is the profiler. Mass spectroscopy measures the mass-to-charge ratio of ions, allowing scientists to identify and quantify molecules. Whether you're analysing the components of an ancient artefact or identifying pollutants in water, MS has you covered. We can't forget infrared or IR spectroscopy, which lets us peek into the vibrational modes of molecules. Ever seen the fingerprint region of an IR spectrum? It's as unique to a molecule as your fingerprint is to you. And what about Raman spectroscopy? Named after Indian physicist C.V. Raman, this technique studies how light scatters off molecules. It's especially useful for studying materials without needing to destroy them. Perfect for art restoration or even forensic science. Here are a few fun tidbits about spectroscopy that you can use to impress your friends, or at least your nerdier ones. Did you know that spectroscopy is how we discovered helium? In 1868, scientists observed a mysterious yellow spectral line in the sun's light, which turned out to be helium, a full 27 years before it was discovered on Earth. Spectroscopy also helped confirm Einstein's theory of general relativity. By analysing the redshift of light from distant stars, astronomers provided evidence that space-time is curved by gravity. And here's a weird one. Some animals, like mantis shrimp, have built-in spectrometers. Their eyes can detect polarized light in a broader range of wavelengths than humans, giving them supervision. Now, let's shine a spotlight on an extraordinary scientist whose work has had a profound impact on spectroscopy and its applications. Dr. Rosalind Yalow was a pioneering physicist who co-developed the radioimmunoassay, or RIA, a technique that uses radioactive isotopes to measure small concentrations of substances in the body. While RIA isn't a spectroscopic technique in the traditional sense, it relies on principles of isotope tracing that overlap with spectroscopic methods. Yalo's work revolutionized endocrinology by allowing precise measurements of hormones like insulin, which were previously impossible to detect. In 1977, she became the second woman to win the Nobel Prize in Physiology or Medicine. What's particularly inspiring about Yalo's story is how she overcame systemic barriers as a woman in science during the mid-20th century. She was once told that women didn't belong in graduate physics programs, but she persevered, earning her PhD and changing the world through her discoveries. And that brings us to the end of today's episode of Proving the Concept. From Newton's prism to the Nobel-worthy discoveries of Dr. Rosalind Yalo, spectroscopy has illuminated the world in more ways than one. If you enjoyed this episode, don't forget to subscribe, rate, and share it with your fellow science enthusiasts. And if you have a topic you'd like us to explore, reach out. I'm always looking for fresh ideas to prove. Thanks for listening, and remember, science isn't just about asking questions. It's about finding the right spectrum to answer them. Until next time, keep questioning, keep exploring, and keep proving the concept, you curious minds.